In this last video, we're going to be looking at another way to analyze these kind of compound event problems, which is the Venn diagram. Now, we'll only be using Venn diagrams for inclusive events because inclusive events have overlap, and that's what Venn diagrams are used for. Two different categories that have some overlap in the middle. In this example, we're going to be looking at a driver's survey. So 3,510 drivers were surveyed. 1,950 of them were male, and 103 were colorblind. Only 6 of the colorblind drivers were female. What is the probability that a driver was male or colorblind? Now you could try to figure this out just using the formulas we used in the last couple of videos, but it would probably be a little bit challenging. It is possible though. One way to help yourself visualize what's going on is to make a Venn diagram of this information. So the big box is going to be our entire survey, our entire data set. So this big box is our 3,510 drivers. Now we have to pick categories for our two overlapping circles. Well, you might be tempted to pick categories like male and female, or colorblind and not colorblind. The issue there would be there's no overlap in those categories, which means there wouldn't be any middle. So we need to pick categories that do have some overlap, which means in this case we could pick something like male for this circle and colorblind for this circle, because there are some males who are colorblind, so there is some overlap here. Now, we can't just start throwing some numbers in here right off the bat because we have to carefully think about what goes in what circle. Specifically, we know that there are 1,950 male drivers. So that means that this entire circle over here is 1,950. But that's between the two pieces, the male and not colorblind part, but also the male and colorblind part in the middle. We also know there's 103 colorblind drivers, but again, that's the entire colorblind circle, the part that's not male and the part that is male. One number we can actually put in here, though, is we know that there are 6 colorblind drivers who are female, or in other words, not male, which means we can put that 6 over here because they are colorblind, but they don't belong inside this male part of the circle. Well, if we know that there are 6 colorblind drivers that are female and 103 total colorblind, we can do that 103 and subtract off the 6 to get that there must be 97 colorblind drivers who are male. 97 male colorblind, 6 female colorblind. Well, this then lets us find how many male drivers there were who are not colorblind. We take the 1,950 and subtract off the 97 from the middle, which will give us 1,853 male drivers who are not colorblind. They are not in the colorblind part of the circle. So this should make answering our question a little bit easier here. What is the probability that a driver was male or colorblind? So the drivers who are male or colorblind are just the 1,853 plus the 97 who are both plus the 6 who are colorblind. So 1,853 plus the 97 plus the 6. This adds up to 1,956. And we know that this is out of the 3,510 total drivers who were surveyed. So 1,956 divided by 3,510 gives us about 0.557 as our probability that a driver is male or colorblind.